In question 10, we're asked to sketch the graph y equals f of x for values between x values between -5 and 10. So this is going to be a calculator question. So on your calculator page here, we want to put in a fraction, and on the top we want it to be x squared, and on the bottom we want it to be x minus 2. So I'm just typing it in exactly as it appears on the exam question, and it looks like that. Okay, now it does say that the domain is -5 to 10, so we're going to change this to -5, enter, and then 10's over here. Now I can't see what's going on up here, so I'm going to make this number a little bit bigger. I can see that the scale on your graph, if you have a look in the exam, they've given you -20 up to 20, so I'm going to set my window to be the same. So double click down here, -20, and double click up here to put it at 20. And that's the sketch that you want to be drawing. So you're going to get one shape, one mark for getting the shape right. So these two curves here, and you're going to get one mark for showing that there's an asymptote between these two curves. So the curve doesn't exist where x equals 2. In fact, it says that here, x equals 2 is an asymptote. So your sketch should look roughly like, it's not going to be a great one, something roughly like this. Let's have a look where it comes up here. So in fact, before I finish the sketch, I'd probably just check where this maximum point was and where this minimum point was, for two reasons. One, it's going to make my sketch more accurate, and two, I need it for the next question anyway. So if we're trying to find the maximum point, it's menu, analyze graph, find maximum. For the local maximum, I can see the turning point is around here, and it gets higher and higher and higher, then it turns round. So the maximum is between here and here. So the maximum is at 0, 0. And then the local minimum point is here because it gets smaller and smaller and smaller, and then turns round. So menu, analyze graph, find minimum. Between here and here, would it be at 4 and 8? So when you sketch your graph, it's got to look like it's got a maximum at 0, 0 and a minimum at approximately 4, 8. So this is a little bit, well, let's see, 10's there. It's not that bad. 4 round about here. Probably should be a little bit lower, okay, because I want it to be at 8, and I can see that that's clearly not going to be 8, is it? So maximum, local minimum here at 4a, so that's the answer to B part 2. And then the local maximum we said was at 0, 0, so it gets closer and closer and closer. 0, 0, oops, shouldn't have gone over that line, and then it turns round, okay, so 0, 0 here. Now we also said that it had an asymptote at 2. To show that it never crosses this line, we usually put it in a dotted line, and if you wanted to be extra brownie points, you'd actually mark 2 here on the x-axis to show that that's where it doesn't cross. So 1 mark for the shape and 1 mark for the asymptote. In part C, I'm asked to write down the range of f of x for all real values of the domain. So for all x values, what are the possible y values that come out? Well, if I change the zoom on my graph, I can see that the y values just keep getting bigger and bigger and bigger and bigger and bigger as the x values increase. And I can see that as the x values decrease, the y values also decrease. So there's no ends to this graph. So it's going to be all the way up here, keep going, and down here, down here, down here. However, I can see that nothing exists between this minimum point and this maximum point. If you look here, all of these y values don't exist in the function. Okay, so we have to try and write this. We want all the y values below this point, and we want all the y values above this point. Well, if we think back, we said that this was at 0, 0, and we said that this was at 4, 8. So if we think about the range, that's just the y values, just the y values. So if I was going to write this bit up here, I'd say f of x, that's the range, the output, is bigger than or equal to 8, okay, bigger than 8. And down here we want everything below 0. So from this part I'd say f of x is less than or equal to 0. And we can't put them together because they don't join up, there's nothing in between. So we just write f of x is less than or equal to 0 and f of x is bigger than or equal to 8. Write down an integer value for k for which f of x equals k has no solutions. Well, if f of x equals to k, that just means it's going to be a straight horizontal line. So for example, f of x equals to 20 would be a straight line across here, y equals 20. But I can see that that's going to have two solutions. Well, depending on if you look at my dodgy sketch, it should have two solutions. Okay. If I put a line exactly at 8, it's just going to have one solution. Okay. If I put a line anywhere less than 8 but greater than 0, then the line is never going to cross the graph. Okay, so you can pick any integer value between 0 and 8, or in other words, you could have 1 or 2 or 3 or 4 or 5 or 6 or 7. Let me just explain that one more time on a fresh sketch. So this graph goes up to 0, 0 here, and then there's another part of the graph which comes something like this, and this stops at 8, this stops at 0. So if I'm going to put a line f of x equals, I could put it anywhere between those two numbers and it would never cross the graph. Okay, so 1, 2, 3, 4, 5, 6 or 7. Okay, part F says to sketch the graph of y equals x plus 2. So x plus 2, what do we know about that graph? Well, it's a straight line and it's going to cross the y-axis at plus 2. So that's what you're looking for to get a mark there. If you did draw it on a calculator, you'd see that actually the blue graph and the red graph don't intersect in our range, or in our domain, so they shouldn't cross over. So I'm going to try my best without a ruler here, but something crossing at 2 and a straight line not crossing the graph there. So this would be the graph of y equals x plus 2. You didn't have part 2 on your exam, so we'll move on to G. It says sketch, this time sketch 1.5 to the power of x plus 10. So this is a calculated job. So menu, graph entry, 1.5 to the power of x plus 10. Now this graph looks like that. So you have to add that to your sketch. The key thing here is the shape and really where it crosses the y-axis. So you might remember from your work on exponential functions, well, at the y-axis, the power of x is 0. So if you have anything to the power of 0, it's going to cross at 1. So if it was just 1.5 to the power of x, it would cross at 1. But then we're adding 10, which means it's going to cross at, it's going to cross at 11. So if you're drawing a sketch for 2 marks, you'd want to add on where it crosses the y-axis, which is at plus 11. Then you want to make sure you get the shape right as well. So it's this exponential curve coming something like, something like this. Now at this point, it'd be a good idea to label each of these graphs because it can get a little bit confusing. 0.5x plus 10. For this last question, I've just taken a screenshot of the TI Inspired to make it a bit clearer. So the black graph was the graph of g of x, and the blue graph here was the graph of f of x. So this question says, when is the black graph smaller than the blue graph? Okay, well if we go from left to right, to start with the black graph is bigger. I'm just going to make a note here. We want the black graph to be smaller. Okay, so at this point the black graph is bigger, the black graph is bigger, the black graph is bigger. Now that's true up until the asymptote, because have a look what happens at the asymptote. So here, up until this point, the black graph is still bigger. Once we pass the asymptote, once we cross over here, okay, the black graph is now smaller and the blue graph is bigger. So this bit here satisfies our inequality because the black graph is below the blue graph. Now after we pass this intersection point here, the black graph is bigger again. Remember, we want the black graph to be smaller. So the only part that satisfies my inequality is this little bit here. So we need to write this in the correct notation. So we want all the x values between something and something else. Well, when did they cross over? Well, the g of x became smaller after the asymptote. So we're going to say after 2, because that's where the vertical asymptote was, x equals 2, the black graph is smaller, and that is true up until the two graphs intersect. So using my GDC, I could find that point there by doing menu, analyze, intersections of here and here, and I can see that the x coordinate for that is 2.485. So up until x is 2.485 or 2.49, then the black graph is smaller. After that, the black graph is bigger. So that's the solution to the inequality.